All right, so our first question that we're going to deal with in preparation for the test is number patterns, right? So let's observe this type of pattern that we have here, okay? We need to first decide, is this a linear or an arithmetic sequence, or is it a quadratic sequence or quadratic pattern? Okay, so you guys have done these questions before in class, right? So a linear pattern, what do we do? Or how can you tell if something is a linear pattern or an arithmetic sequence?
There's a common difference.
Perfect, right? Common difference. We work out common difference by saying T3 minus T2. It should be equal to T minus T1. For this one, this is your T1, your T2, T3, and T4. So the common difference, okay, has to be the same for it to be an arithmetic sequence or a linear pattern. All right, so let's work out what D is here. If I take T3, that's 14 minus 9. That gives us 5. Then if I were to test T2 minus T1, okay, that's 9 minus 4, which also gives us 5 here, okay? Even with the 19 minus 14, that's also going to give us 5. So we have a common difference of 5. Okay, now what's the formula for an arithmetic sequence or a linear pattern? Tn equals what?
A plus it's D in brackets in minus 1.
Okay, perfect, right. Now, A, remember, stands for the first term, okay? And D, we already know that's your common or constant difference, okay? All right, now, we've worked out what D is. A, we take it from that pattern, so that's going to be 4 plus n minus 1 multiplied by D, which is 5. Okay, you can write it like that, okay? So nth term is just basically Tn. So we've done the first question. You don't have to distribute anything. You can just leave it like that, okay? Some people do like to distribute the 5 into the brackets, but there's literally no need, okay? Then they say, is the expression for Tn linear or quadratic? This one is linear because we have a common difference. Because there is a common difference. And sometimes you can even write common difference of what? Of 5 between the terms. Then they say use Tn, okay, which is the formula we just worked out, to work out the 50th term. Okay, so we need to find T50. So where I see n, what am I doing? I'm substituting in 50. So you're going to have 50 minus 1 there multiplied by D, which is 5. Right. So let's simplify the 50 minus 1. That's 49 multiplied by your 5. Okay. Plug everything into your calculator, and the answer for T50 is 249. Okay, that would be your answer for T50. Then T4, which term in the sequence is equal to 114? Right, now what's the difference between T3 and T4? So they've told us that there's some value Tn, which is equal to 114. They're asking us to work out which term in the sequence. They're asking us to work out n, which is the position of the term. Okay, so for this one, you're going to say 114 is equal to 4 plus your n minus 1 multiplied by 5. Okay, we need to make n the subject of our formula. All right. First things first, balancing method or your inverse operations. You're going to take the plus 4 over, it's going to become negative, right? N minus 1 multiplied by 5 is what's left on the other side. So 114 minus 4, you're left with 110. and n minus 1 multiplied by 5, okay? So at this point, right, since you're multiplying by 5 on the right-hand side, you want to get rid of that multiplication by 5. So that means we need to divide by 5 both sides. N minus 1 is what you're left with there. 110 divided by 5, that gives us 22. So n for this particular question is going to be 22 plus 1, which gives us 23. Okay. Any questions related to this type of question? Nope. Okay, now let us go on to sketch the graph of 2 cos x. Let's do that one. And then let's sketch the graph of sine x plus 1 for the interval between 0 and 360. Okay, so they'll ask you only to sketch one, but for practice, we're going to sketch both, right? So we want to sketch the 2 times cos x plus 1 and the sine x plus 1. All right. So now looking at these things here, right? What's happened or what's going to happen to this? So we know the cos x graph, okay? The cos x graph looks something like that, okay? And this is from 0 to 360. Okay. If you don't know the shape, remember we said you can use your calculator to create your table of coordinates, okay? And then plug it in to your calculator, get the table of coordinates, and then plot the points. Now, what's going to happen? So this, what I've just sketched is the ordinary cos x graph. Now, if you have 2 multiplied by cos x, what's going to happen to your y values? Remember initially, the maximum value is going to be 1 and -1. But since you've multiplied everything or the entire graph by 2, what's going to happen to your max and your min?
2 and -2.
Perfect. This is going to be 2 here, and this is going to be -2 there. Well done. All right. So that's what's going to happen to your graph. Okay, the max and the min. Oopsie, sorry, I don't know why I just did that. Okay, so it's going to be 2, that's your max. Your min is -2. Okay, everything else stays the same, right? So that would be for cos x. Now, let's think about the sine x plus 1, okay? Now, sine x plus 1, what does it look like originally? Okay, it starts off at 0, like that. This is your 90, 180, 360, this is 270 here. Okay, it's from 0 to 360. What's your max? Your max is 1. Your minimum is also -1. Now, what have they done this time? They've said sine x plus 1. So what's going to happen to your y values or the entire sine x graph here?
Gonna shift up a 1.
Perfect. So the entire graph is going to shift up 1 unit. So what do you think your new max and min values are going to be? Okay. So we're shifting the entire graph upwards. Okay. It's going to be the same shape. The shape's not going to change. The only thing that's going to change here are your max and min. So when I redraw it's going to look like that. Okay, so now you have a new point, which is your maximum value is 2, which is that. This is 1. This is 0. Okay. So now we've shifted the entire graph up 1 unit. Okay. So now this here is your 90 degrees. This is 180, this is 270, and this one is your 360. Okay, so initially it was 0, 0, but now this, so remember you have to show all your turning points, intercepts with your axes, etc, right? So the maximum point, that is 90 degrees and 2. This is 0 and 1. Okay, this one is this point here, which is an intercept, is 270 and 0, and 360 and 1. Okay. So you've got your endpoints, your shape is correct, your maximum, minimum, intercepts, everything is shown there. Okay, for the other one, again, this is 180 and -2. This one is 360 and 2. Here you had 0 and 2. This one is 90 degrees and 0. 270 and 0. Any questions? No? Does it make sense? Yes, no?
Yes, ma'am.
Okay. All right, perfect. Okay. Now, do you guys have any questions that you want us to go through in particular before I go on to, because sometimes you guys have questions. No one emailed me anything, but I'm thinking you may have questions that you want to ask before we move on.
Ma'am,
Yeah.
can we please do negative cos -2 cos x plus 3?
Okay, so sketch -2 cos x plus 3. Okay.
Yes, ma'am.
What interval do you want us to do it in?
What does that mean, ma'am?
Okay, so when they ask you to sketch this, they'll say between intervals so and so. So for the one above, it was between 0 and 360. Sometimes they can also say from negative.
Oh, yeah.
Okay, so for this one,
0 and 360, ma'am, please.
okay, cool. So from
Thank you.
0 to 360. Right. Now,
Yes,
I'm
ma'am.
going to, so for the test, let's say they've given you something that looks like this and you are stuck. Take your calculator. I'm hoping you have a Casio, right? If you have a Casio, press mode and then select the table option. I think on your calculators, it must be option 3, right?
Yes, ma'am.
Perfect, right? Now, there's going to be something that says fx equals. With that fx, I want you to type in -2 cos x, okay? Close brackets, then plus 3. If you don't close brackets, your answers are going to be wrong, okay? I'm glad we're doing this together. So -2, press the cos function. So automatically when you press cos, it's going to have a bracket. To punch in the x, press alpha and the curved bracket, which will give you x. Close brackets straight after the x. If you don't do that, your answer is going to be wrong. Then after you've closed your brackets, then it's plus 3. Okay, press equals. You're going to get something that says g of x. Leave this blank. Okay, just press equals again. Okay, then it's going to take you to something that says start. Now, our start point is going to be the interval they give us. So can you see here for this one, starting point was 0. So we're going to start at 0. Okay, so punch in 0 there. Your end point, any ideas? Guess what your end point is for this one?
360.
Brilliant. So you've put in 360, you've put in 0. Now, the trick If they give you a graph or graph paper, on your graph paper, there should be an axis, right? Sometimes you'll see that the axis looks like this. They've just given you axes and then it goes 30, 60, 90, like that. If it is like that, then your step should be 30. If not, you can just use 45 degrees, okay? So for today, let's use 45 degrees. If you use step 1, you're going to get an error. It will say insufficient memory. So for trig, let's choose the default step of 45. So you're going to type in 45 there, okay? Press equals. Okay, now you should have X values that it gives you, right? And then it's going to give you f of X values. The first one that it gives you is 0 and 1. Second one is 45 and 1,5857. Tell me if I'm wrong, guys. 90 and 3. 135 and 4,4142. 180 and 5. 225. Now it starts turning back and it's going downwards now again. And then 270 and 3. 315 and 1,5857. And the very last one, 360 and 1. Okay, now these are the points we're going to plot on our graph. Okay, like I said, they'll give you graph paper. Then we're going to plot these points. Okay, first point they give us is 0 and 1. So remember the maximum value that we get here is 5. So let me just extend my graph a bit here. I'll make that 5. All right. So first point is 0 and 1. Okay. Then the next one is and we're going up in 45s. Okay, so 45, 90. Okay, so let's go ahead and plot. So 0 and 1, I've put my first point. Then I'm gonna plot, you don't have to plot the 45. I'm gonna choose the points in between, the most relevant ones. And then 180 and 5. Then 270 and 3. And 360 and 1. Something like that. So negative 2. So now it looks something like that. So this makes sense. Why? Because remember the original cos graph looks like that, right? What does the negative 2 mean? It's been reflected. That's why the shape is flipped, okay? It's now shaped the other way. You flip the entire graph if there's a negative sign there. Then what's happened? It has been shifted up how many units? 3 units. Which are the points we need to plot? We're going to plot or show on the graph 0 and 1. This maximum here, which is 180. And this is 5. And the end point here, which is 360 and 1. Okay, there we go. Make sense? Does this help, guys?
Yes, ma'am.
All right. Okay, perfect. So if you're stuck in your test, that's what you do, okay? Don't leave it blank. Use your calculator. Okay. All right. So any other questions? Oh, a chat question. Can you please show how an example of a quadratic pattern? Okay. I don't think you're going to get quadratics, but okay, let's look for a quadratic pattern. Just give me a second. Okay. Okay, I'm just looking for quadratic type patterns. Okay, I'll be with you now. You guys said that you definitely did do quadratics, right? Because I don't want us to do something that won't be there. Yes, no? Did you guys
I
start?
don't think,
Huh?
I don't think my class didn't touch it.
Okay, fine. So one class hasn't done it. That means the other class is not going to do it, definitely. So there are no quadratics.
No.
Okay, perfect. So no quadratics, so we don't need to do that one. Okay, we've got 10 more minutes. Okay, let me just see if there's anything else. So all the other types, the sketching type stuff that we've done, okay? Remember, there are also videos that we've done previously. Go to those. All those examples that I did, very useful. The functions one, very useful for what's going to come up, okay?
Ma'am,
Yeah, Bill.
will there ever be like a tan, but then with +1 or +2?
Yes. So with tan, if they ask you to sketch a tan graph, okay, there's going to be a point where you get error, okay? That error is your asymptote. So wherever you get error on the tan graph, that's going to be your asymptote. Maybe you want us to do that quickly.
Yes, ma'am.
Okay, so let's sketch tan x plus 1. Okay, we're going to do it from 0 to 360. Okay, so again, put your calculator into table mode, right? And you're going to punch in your tan. The open bracket is going to come up x. As soon as that x, you've put it in, okay, close brackets like that. Then outside the bracket, you plug in +1. By g of x, leave that blank. Your start point, remember I said your start point is 0. End point, 360. Your step, let's make it 40. Okay, yeah, let's make it 45. Okay, now, so what you get now, you're going to get x and then you're going to get fx, okay? For the first one, it's 0 and 1, then 45 and 2. Then at 90, you get an error. So this is our first asymptote. Okay, then 135 and 0, 180 and 1, 225 and 2, 270. Yeah.
When we draw the asymptote for the tan graph, must we show like x is equal to 90 degrees? Or
Yeah,
must
so
we just say 90?
I'll show you now how we're going to draw it on the graph. Okay, so let's start with, okay, so it's like that. First asymptote, okay, that's the first one. This is my 90. So for this tan graph, I'm showing it by doing what? By adding dotted lines like that. So that's the first asymptote, okay, which is x is equal to 90. The second asymptote is at 270, okay, so like that. All right, and then the endpoint is 360, okay. So then the other points, X is 0 and 0, so plug it there. Then 45 and 2. So it looks something like that. So it's going upwards. It's never, sorry, I didn't mean to make it wavy. It's never going to touch. So it continues going straight up. It's never going to touch that graph. Then on the other side, okay, 135 and 0, 1, 2. Okay, so now since we chose 45 here, it's left out some values. But for 10, as you can see, the shape is like that. So this point here, this is going to be 135 and 0, then 180 and 1 there, and 225 and 2. So these values here give you the general shape of the graph. The error, that's your asymptote, okay? And then 315 and 0 and 1. So like that as well. Okay. And it's going to carry on. But for this one, we're stopping at the point where you have 360 and 1. Okay. So to get a complete picture, so these values here, right? Since we used 45, we didn't get all the points in between, okay? So it didn't give us any of the negative values. To get the negative values as well, your step, you're gonna have to change it to 30 degrees. But since you got these values, remember, you know the general theory of what a tan graph looks like. You know it has positive y values and negative y values, and they look like that. But for this one, this particular graph for tan, make your step 30 so that you get your corresponding negative values. Okay, so for this one, it left out important values. That's why we didn't get the negative ones. Okay, right. So that was your tan graph. Okay, so I'm going to release your CF ruler assignment. Like I said, your CF ruler assignment is linked to what's in the test. Okay, so to get a thorough depiction, or what do you call it, like an example of the types of questions to expect, do the CF ruler assignment. Okay, so we have 5 minutes. Let me see if I can pick out a question that I think would help. Right, let's see. Okay, so asymptotes we know already, axes of symmetry. Okay, so quick recap. Okay, so let's say you have the following hyperbola. Okay, write down the asymptotes. Okay, so what's the first asymptote for this one? What do you guys think? Okay, the first one.
Is equal to 0.
Right, x is equal to 0. And then the other one is?
Y is equal to 2.
Brilliant. Okay, now very important. Axes of symmetry. How would we do that? Okay, if you weren't here last time, for axes of symmetry, we said we always look at the denominator with the +2. So the first equation for the axis of symmetry, y equals x plus 2. Then the other one, okay, remember, is negative x plus 2. Okay, like that. Okay, sketching this type again, what would you do if you don't know the shape? Plug it into your calculator and knock it out. Okay, right, then if you had y equals 2x plus t squared plus 9, okay, what type of graph is this? This is a, right. How do you work out the x? Okay, so for this one, it's not going to have 2. It's going to have 1 axis of symmetry.
X is equal to 0.
Brilliant. Okay. Why? Because this one looks like that. It's shifted 9 units up and it's symmetrical about the line x equals 0. So instead of axes of symmetry, they could also ask you, what is the turning point? What is the turning point of the graph? The turning point is this point here, which is 0 and 9. So the turning point, x is 0, y is 9. Okay. Now, what's other important stuff here? So axis of symmetry, turning point, right, range and domain. What would the range, okay, and the domain be for this graph? Then we'll go back to the hyperbola. So range, remember, relates to your y values. Domain relates to your x values. What's the domain for a parabola?
Is an element of the reals, but can't equal 0.
It can, for this one, it can. For parabola, it can. So x is an element of real numbers because you can substitute 0 here. Your equation is going to be just equal to 9. Now
Is
you
it only for hyperbola, ma'am?
yes. It's only for
Right.
hyperbola. Good. And then the range for this one, we've got less than a minute. This is going to be y is greater than or equal to 9. Let's go to this one. Okay, this was so domain for this one, x is an element of real numbers, but x cannot be equal to 0. Domain for this one, y is an element of real numbers, but y cannot be equal to, not 0, 2, which was your asymptote. Okay. Awesome, guys. It's about to run out. Well done. I'll release the Siavula assignment. Happy studying. If you have any questions, please send me an email. Okay.
Thank you,
Awesome.
ma'am.
Thank you.
Thank